Sorry, his camera is on. Pam, his camera is on.
Okay, then he can come, they can see him. Luanda, when you speak, will you turn your camera on, please?
Oh, I thought you were, oh, no.
So, okay, but I'm going to just briefly introduce you, and I know this is quite exciting. So to all our grade 10s out there, we have an intern. So an intern is where you train in a profession. So he's obviously training to become a geography teacher. But what I like about his CV is he tells me, like so many other people do, is they discover their love for geography when they're out in the field. And he would visit his grandparents near Nkandla and near the Tugela River. So he would have had amazing scenery out there and the almighty Tugela River, which can be quite fearsome when in flood. So that's where his passion started. And thumbs up, he went to University of Pretoria. I think they're excellent. And he discovered by chance that there was something called remote sensing and GIS. So he went to university not really thinking he would do that. So it just shows that this is a well-kept secret, and this is why we're having this webinar. And so he so enjoyed what he was doing in the remote sensing and GIS, he completed his honors and master's degree in these disciplines. And you'll notice honors and masters. So today, a degree is just the first stepping stone. You need to continue your studies. And certainly I'm going to hand over to Yanda now, who'll tell you a little bit about why you should do geography and which subjects, why it's an important subject. Over to you.
Oh. Okay, so I think one of the many loves that I have for GIS and remote sensing is it's definitely its many uses in different industries. A lot of people always think that geography and GIS and remote sensing especially can just be used for geography applications. But then the thing is that as you actually read more about it and you learn more about it, you can find that a lot of times GIS and remote sensing can be used in banking, can be used in governance, can be used in construction. It can be used for something so small as just checking if you have like a crack in your house to actually seeing how much of crop do you have in the field of farms. So for me, I remember with my honors year, you know, I'd only known about GIS in terms of just creating maps. But then when I got into my honors, one of the many applications I was able to do was to actually to find a new site for landfills. And that was just simply using satellites in space. And I was like, this was really, really incredible. I did not know we could actually do that. And I did pretty well in the write-up for that. And then when I did my master's, I got to a point where we had only known about American satellites, and apparently we got to a point where I was able to evaluate the European space satellites that they were using, which were boasting very, 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 very amazing technology on them. And now that I'm actually looking at the more technology go through, you're actually seeing people now commonly using Androids. Using drones to actually to apply GIS, which opens a new field and more applications for it. So yeah. Are there any questions? Anyone?
Questions in the chat, grade 10s, if you want to jot down any questions for Mr. Nzama in the chat.
I think that people are just a slight nervous.
Well, we're waiting for a few hundred to quickly join, but I've got a question, sir, if that's okay.
Yes.
When did you first find out about remote sensing?
Oh, remote sensing, I found out at the same time as GIS, which was in second year, which was in 2010, 2011. And at that point, the only way you could ever apply to do it was in front of a computer using specific programs and using specific satellites in order to actually apply it. But then now it's actually come a very, very long way. And yeah, I loved it from there. You know, the ability to use a computer just to see the world. And that's a very important thing. What's that again?
Can I read out 2 questions here? Ria's got one. Isn't privacy an issue in remote sensing?
No. The thing is that one of the many things about satellites is that they still need to adhere to international laws. So you can't just go around and say, you know what, I feel like just spying on a certain on someone's house. And I know that there are some countries, like I think if you look on your Google Maps, which is remote sensing, you find that there are some areas that have much more clear images than others, mainly because of important features that exist there that they don't allow out. But I've never had an issue with with privacy, as far as I know. And there has been application for it. I mean, the US uses it for their intelligence, I think. So, but then as a private citizen, you should not have an issue with it.
Thank you. And the next question, Jaden. Thanks. Good question, Jaden. What other subjects do you need if you want to study in this direction besides geography?
Ooh. I think one of the very obvious ones is mathematics. That comes in handy because one of the many things about remote sensing is not just simply using the satellite, but then actually interpreting the information. So having mathematics and being introduced to stats actually does help you a bit. I would say computer programming nowadays. If you do computer science in high school, that would be that would be very good. If it's too late for you to do IT, you can simply do it at university level. UP has an amazing program where they actually introduce you into programming and using computer science in order to integrate remote sensing and GIS as well.
Thank you. And Mr. Nzama, one last question, and then I think we need to start the program. There's one from Mr. or Miss iPhone, which says, what subjects do you need to study geology? I assume exploration geology with remote sensing, perhaps.
Yes. I did geography in high school. And then when I got to university, my undergrad was in geology, and that's how I discovered GIS by mistake because I had to do electives. So in exploration geology, they are starting to use more remote sensing. So I think that if you go to university, the very important thing that you need to do is that if you make it into geology, is be able to do stats as well as your electives, as well as GIS, because a lot of companies, private companies, are looking to people who have that skill set in order to use them, how to interpret that information and the pictures that drones are able to take in order to interpret geology. Hope I answered the question.
I think you've answered the question beautifully. Thank you. I think, Pam, I think we've got to, and thank you so much, Mr. Nzama, for coming in while we were sorting out all the other participants to join. Over to you, Pam.
Thank you. It's my privilege to introduce our guest speaker, one of our guest speakers. But before I do, I'd just like to add to that geology aspect. So if you're going into geology, what is good too is to diversify a little bit in the field. And Luanda has mentioned looking at stats and remote sensing, but I would say even doing a course or two in economics, because geology is also about the use of resources and the economics thereof. So that's another idea you could look at. Right, so without further ado, I want to say congratulations to everybody for choosing geography. And if you weren't in geography, you wouldn't be at the seminar, and we wouldn't have one of my favorite speakers, Mr. Dan Matsapola, to speak to us. He is an African space scientist. So his training would be in physics, satellite engineering, and even business management. So he's the founding member of SANSA. So you would have seen the logo up there, and I'm sure he'll explain it. So that's the South African National Space Agency. And our speakers today will show you how passionate they are about what they do. And every day of their work lives involves 21st century skills technology. So you're going to hear a lot about GIS. You're going to hear a lot about remote sensing, geospatial technology, space, IT, artificial intelligence, drones. And that is where the careers are in the future. So you need to perhaps listen up and see what's needed to pursue careers in that field. Mr. Matsapola is also what currently is the Science Engagement Manager at SANSA in the Earth Observation Division. And so what he does very well is he manages the National Space Awareness portfolio, and he targets African youth in Africa. And he supports STEM education. So we're looking at science, technology, and mathematics. We're looking obviously at economics as well. And that is really about the basis of our knowledge economy. He's the father of 6 beautiful daughters. He has a family business, which his wife runs. It's called Dan Neo. So his wife's name is Neo. And he's just authored a book. And I believe you can obtain a Facebook edition free from the author. And it's called Thriving in the Fourth Industrial Revolution, Beyond Survival. So without further ado, Dan, the floor is yours.
Thank you, Pam, for that wonderful introduction, and greetings to everybody on this platform. My name is Dan Matsapola, hailing all the way from the province of Limpopo. I undertook my studies in satellite engineering at Stellenbosch University, and then I tracked satellites for about 7 years for the South African government before I migrated to the CSIR to work with promoting satellite data and its use in developing countries, a project called Data Democracy for Developing Countries. Of course, CSIR migrated into SANSA, and today I am Science Engagement Manager at SANSA Earth Observation. So what I'm gonna do, I'm gonna share my screen, and then I give you a presentation that I've prepared for you. Without any much ado, let me get straight into that. All right. So SANSA is a South African National Space Agency. It's an agency of the South African government. So I'm very happy to be here to share with you what we do at SANSA broadly, and then we will zoom in into GIS and remote sensing, particularly activities for the grade 10 learners that I've prepared. So we are not astronomers, but it's always important to get the context for what we do. We are somewhere there on that yellow dot there that is pointed on the screen, and that really humbles you and makes you realize that in the greater scheme of things, we are just but a little dot. When you zoom closer into the solar system, you will realize that we are planet number 3 and the most fragile of them all. So far, the only one that we know supports life, all 9 billion people of us, population of us. These satellites, by the way, the natural satellites, my very energetic mother just served us noodles. So I'm sure those who are doing physical sciences would know what that means. All of them are satellites, but they are natural satellites. They have inspired us through the years to conceive and conceptualize man-made satellite. And the first satellite was only launched on the 4th of October, 1957 by the Russians to orbit around the Earth. And in that time, nobody really knew much about what applications you can develop from these satellites and what advantages they can bring, what business intelligence they can provide. But today we have a plethora of satellites that are generating truckloads of information sitting in archives and being used in various industries, as the earlier speaker has said. South Africa is not new to space. We have been involved in space since the very early days of the space race. And in fact, I feature in a book called 50 Years of Space by the CSIR Satellite Application Center. I don't know that the print edition of that book is available, but yeah, I think that communications can help with that. That was 50 years. I mean, there is a brief history where, NASA needed to establish a facility to support the early missions. And of course, it started in Johannesburg, and then in 1960, it moved to Hartbeespoort, which is what that HBK stands for. And they, Stadan was established in HBK in 1961. And of course, we supported NASA missions between 61 and 1975, including the landing of the man on the moon. And so in 1963, of course, the 12-meter parabolic dish antenna was set up in Hartbeespoort, and it is still functional to this day. Of course, due to political pressure, NASA terminated in 1975, and the CSIR took over Satellite Remote Sensing Station. And in 1977, we received the first Meteosat, which is nothing but a meteorological satellite in geostationary orbit, 36,000 kilometers away. 1983 was significant because we joined the French network. And of course, in 1996, post the 1994 democratic dispensation, we were renamed CSIR Satellite Application Center. And in 2011, we joined the newly established South African National Space Agency. So this is the French network that we were part of, and we were part of many other global networks, including the long-serving mission called Landsat that has been imaging the Earth since the 1970s and is the longest record we have of images of the Earth taken from outer space. Of course, access to space is made possible by rockets or space transportation vehicles, as they are popularly known. And increasingly, the world is looking at making them reusable. And guess who? None other than our own Elon Musk is busy showing the world how that is done. So rockets are multi-stage rockets, and they are vehicles for actually ferrying the satellite into outer space, placing it in its rightful orbit so that it can perform mission functions. South Africa has launched at least 4 satellites into outer space. In fact, on the 23rd of February, we will be celebrating exactly 22 years of South Africa as an African spacefaring nation. That is fantastic because those investments that are made in space are leading to serious innovations that are positioning us as a knowledge economy. So 4 of those satellites, the current satellite in outer space is actually called ZACube-2, and it is helping us monitor our oceans. So we are building satellites for particular purposes. So like I said, 22 years as a spacefaring nation. And of course, in 2008, at the transition point, President Kgalema Motlanthe signed into law the SANSA Act number 36 of 2008, which paved the way for the creation of the space agency. SANSA was created really to promote the use of space and to strengthen cooperation in space-related activities, fostering research in space science, advancing scientific engineering through human capital. And this session is a classical example of human capital for the grade 10s, and supporting, of course, industrial development in space technologies. We look to you to stay within the human capital development pipeline so that you can help us transform the South African space industry into productive companies that are playing in various segments of the economy, and right down to the district and the local municipality and the community level. So SANSA has got 3 facilities in Gauteng and the Western Cape. The head office of SANSA is in Pretoria, the Innovation Hub, co-located with space engineering and Earth observation. And you go to Hermanus, where the sun is the major player there for enabling space weather forecasting. You will find SANSA Space Science, and then of course in Hartbeespoort, that 50 years history of space was in Hartbeespoort Hoek, South Africa. It's in Gauteng, but it's just on the border with Northwest Province. What is our vision? An integrated national space capability that responds to socio-economic challenges in Africa by 2030. So space is linked very closely with socio-economic benefits and that we can unlock the value in. Our mission is to provide leadership in unlocking the potential of space for the advancement and benefit of humanity. So SANSA is organized around 4 programs. The engineers who build satellites facilitate the building of satellites with the South African space industry. You've got the space operations that interface using those powerful antennas at the ground station to communicate with satellites in Earth orbit and to support those launches that go up from various launch sites around the world, and to, of course, monitor carrier signals for various satellites. At Space Science, as you can see, the sun there is spewing out, coronal mass ejections, solar flares in all directions, including the direction of the Earth, and that can cause disruption to space-borne technologies as well as ground-based technologies, including grounding of aviation sector. So increasingly, we are becoming a strategic partner for the aviation sector on the entire continent of Africa. Earth observation is the home of the geographers, so I'm sure the grade 10s will find a home playing around with satellite images. We're broadening our focus now with the 2020-2025 planning horizon. We are broadening our focus into the entire continent of Africa, even though we are located within the Southern African Development Community. And why Africa? Because Africa has got a development agenda called Agenda 2063, the Africa we want. We are a very youthful continent, and our size is very clear, can fit many other countries. I mean, US, China, and India can both fit on the all fit in the African continent. And that just tells you how big we are, 30.2 million square kilometers. So of all the various applications, and you can see we are surrounded by ocean, which means that ocean economy becomes critical to unlocking the economy of Africa. And we do have a youthful population of 420 million young people aged between 10 and 35, which means in satellite technology terms, we have a launch window during which we can capacitate our young people working with educators in the school systems and positioning them to become knowledge workers in an increasingly knowledge-driven economy. So Earth observation via satellite is concerned with the interaction of light with features, and we deal with like active and both active and passive sensors, which are satellites that depend on the sun's radiation to measure reflected energy to characterize the nature of the features that that light interacted with. But then active sensors are those that are generating their own independent illumination such that they don't depend only on the sun. They can work at night, even during rainy days. In cloudy days, they can penetrate cloud, which makes them very versatile for almost 24 hours service type operations, including military applications. So that is the entire value chain with the ground station interfacing between the users and the satellite. And of course, the applications development, which is the key work of the Earth Observation Division at SANSA. So we are transforming terabytes of Earth observation data into information that is very handy in the hands of a decision maker and the policy maker who are increasingly pressed to make policies that are informed by scientifically sound evidence. So science is at the very core of innovation and unlocking massive socioeconomic benefits for society, geography being a science itself. And of course, our image acquisition coverage at SANSA, this is Hartbeespoort Hoek. It's about 2,500 kilometers in radius, centered in Hartbeespoort Hoek, the XY or latitude, longitude coordinates. There's a GPS coordinate there, 25 degrees south. So all missions in space are driven by human needs. from the very beginning of the space race. It was seeking advantage over other people for those who were competing with one another. But today, we are using space technology increasingly to preserve the livelihoods and ecosystems that are interconnected on planet Earth as the most fragile planet that we are aware of, and that our entire livelihoods are connected to this. So climate change, sustainable development goals, and of course, natural disasters are three of the key drivers of the use of space science and technology today. So we are seeking innovations in that regard. So in my unit, I'm Science Engagement Manager. I deal with 4 elements in pursuit of the development of a critical mass of skills required to carry out space missions. 1, we stimulate multidisciplinary thinking through science engagement. 2, we support STEM education, and Pam has already defined what STEM is. For the knowledge economy. 3, we promote the innovative use of space science and technology by the youth, in particular those space products and services increasingly finding themselves on your mobile phone. And so we come to your classroom and we help you start being active users of space science and technology to solve current problems, not wait until you are graduates from university. And of course, I'm a science communicator. So we profile career opportunities in space science and technology. And our mandate is national with an increasing focus towards the African continent. This is a GIS map of all the schools in South Africa in the year 2000. I am sure that the current 2021 edition of this GIS database will be more interesting. But yeah, your school is in there somewhere and you are able to query and search this database and make informed decisions. And so we engage with learners in the school system through various platforms. Mass participation platforms include science festivals distributed nationwide. And of course, we have the full support of the South African government with another mass participation program called National Science Week, which we encourage all schools in South Africa to be part of. For us at the Space Agency, every single day is Space Celebration Day. We're looking for excuses to celebrate space every day because really space permeates every area of our lives. Of course, one of the things when COVID regulations do allow, we look forward to hosting as many of you young people from South Africa to our satellite ground station in RTBS Hoek and showcasing the work that we do in that part of the space value chain. And of course, we do come to the classrooms and we engage. We have classroom activities. Check this out. I have a satellite simulation software that I used to use to track satellites. Today, I'm helping young people to see what the work of a satellite technician is when they communicate with various satellites in outer space and to plan for tracking those satellites as the part of the remote sensing process. And of course, from this, you can derive a lot of many insights around space science and technology. And so in terms of stimulating multidisciplinary thinking, space science and technology is unparalleled. You only have to go back to the days of Aristotle, who thought when looking out, he thought that, well, this earth doesn't look like it's moving. And so concluded that the earth is the center of the whole scheme of things and that the moon, the sun, and all the other wanderers, which is what they called other celestial bodies, were in perfectly circular orbit around a fixed, unmoving earth. Today we know Earth is not only moving, it's rotating around its axis and it is orbiting around the sun, completing one orbit in 365.25 days. So multidisciplinary thinking is a real requirement to play in the space industry. And as you know, Sir Albert Einstein said to us, education is not just the learning of facts, but the training of the mind to think. So those classroom activities are meant to stimulate thinking. Okay, so what have I prepared for you, grade 10 learners today? You are part of the target audiences that were identified in the cabinet-approved Science and Technology Science Engagement Strategy in January 2015. Your very school address is an application of global navigation satellite systems, GPS being the American example. There are Russian and European and Chinese and Indian, other, GNSSs, of course. So increasingly they are converging in your mobile phone. And when you check in at the airport, when you send your friend a WhatsApp location, all of that is embedded in your cell phone technology and allows you to navigate safely on the surface of the earth. Satellite images of your schools, we the guys who make sure that you at least get to see it over time and see what changes have taken place over your school, and to see how they can help you to take decisions about changing your behavior. Like we've had to now get used to wearing this thing. You can take corrective action if you see that the number of trees on your school premises are decreasing. That is not a good thing from a climate change mitigation perspective. And we play with high and low spatial resolution. By the way, grade 10s, there is no satellite image that is useless. There are satellite images that are useful for particular applications. And of course, if you are looking for zooming into a smaller area, you may want to use higher resolution satellite images. But if you, of course, you are doing regional studies like Southern African Development Community, then you need to be working with much coarser resolution. You can do with Google Earth Pro and other public domain platforms, school area measurements and perimeter, which is information that's useful. And as a science club at your school, because geography is a science, you could be simulating entrepreneurial opportunities like number 9 there. You could have the school governing body as your client in keeping learners safe in school, because that perimeter wall needs to be erected, and that requires calculation of the perimeter's length and stuff like that, which informs the material that's required to put safety for the kids. Like I already spoke about tree density over time. Open area, not just in school, but in your area. Land consumption rate is one of the sustainable development goals, because it talks to sustainability in us using the resources of the earth and how vulnerable we are to overusing them, and thereby causing serious problems in future, mortgaging the future of our children. Disaster management, we've just seen Eloise sweeping through east-west direction, affecting various communities in South Africa. And I know RadarSat, one of those radar satellites that the Canadians have, was tasked by SANSA to take images over specific affected areas as we work with the National Disaster Management Center. So 420 million young people distributed over the continent of Africa gives us a launch window to transform the trajectory, economic trajectory of Africa, not as a dependent community, but as a meaningful player that can feed the world. I mean, we sit with what? Over 60% of the world's arable land. And yet we are importing, I'm told, $35 billion a year in food we should be producing. And I'm glad that the rains are coming back. And you can see the critical applications of Earth observation in delivering that value and helping more and more African countries that we are seeing embracing space science and technology, forming space agencies, launching satellites into outer space. Even our neighboring Zimbabwe, I hear they are about to launch their own satellite. They formed their space agency about 2 to 3 years ago, which is fantastic. It means that now more and more African children get exposure to space science and technology as a driver of innovation. And of course, we expose you to the different orbits, from low Earth orbiting satellites, which is where all of South Africa's satellites were destined, GNSS satellites that are largely in medium Earth orbit, and of course, the mighty geostationary Earth orbit, which is what gives you 24-hour direct-to-home television, among other application areas. At schools all throughout the country, we go and we help young people to get comfortable with taking GPS coordinates of their schools, and then we show them using Google Earth Pro how they can, help with mathematics exercises that are hands-on, and you can calculate perimeter of the schoolyard, even though the school fence has dilapidated. And so you can generate that data set yourself. Science clubs are the key. This is a pilot we are doing in the province of Limpopo, but now working with the Department of Science and Innovation and NRF SAGTA, we are the agents establishing science clubs all over the country. And we are using virtual platforms, and we are interacting with several space clubs from around the country, giving them exercises that they can do to deepen this understanding of the application, not just the theory of space science and technology, doing the basics, not understanding what a satellite is. That is the biggest satellite ever developed by multiple countries, called the International Space Station. That's where all the astronauts are destined to. So, in a nutshell, we bring the science to your classroom. Of course, the human eye being one of the sensors that we have, remote sensors that can obtain information without being in direct contact with the object from which it derives the information. So 400 to 700 nanometers is the visible spectrum, represented by colors: red, orange, yellow, green, blue, indigo, violet. 400 nanometers is violet, red is about 700 nanometers there. That's physics. Physics of mathematics of a circle centered at point XY or latitude longitude point. In matric, you will get to that. But because you are in grade 10, I know it's not yet in your maths curriculum. But the mathematics of it, it's very interesting. For the teachers, we have uniquely sensor platforms that we expose them to. Here, Charlie Bolden, the one and only former NASA administrator, was here, and the CSIR had him give a public talk at the International Convention Center here in Pretoria. And we, of course, have hosted astronaut Don Thomas at University of Pretoria as well. So we want to work with other organizations within South Africa and increasingly penetrating the African market to expose 420 million African youth to the science, because listen to me, science is the future. Science informs the economic recovery and prosperity of African communities. So farmers, from producing of food right down to the export markets that we need to send food to other nations, no longer importing. That is highly, highly dependent on science, and space science and technology is a priority research area that we look forward to welcoming you into the Earth observation community, not just as employees. In fact, when I go to schools, I tell young people, don't become employees. We have an oversupply of employees today. And with the COVID having disrupted a lot of our economic activity, we know that many employees are in trouble. They are retrenched. They have been asked to take pay cuts. So do not become a dependent. Learn how to become an entrepreneur, a job creator, and utilize these increasingly available space products and services to innovate and to create massive socio-economic benefits, and have other people know what to come to your company for to deliver those services. Of course, we engage with the public. There's the CEO of SANSA, Dr. Munsami, leading public engagement efforts on radio. And of course, in Hermanas, if you ever find yourself in that part of the country, you can visit our Space Weather Regional Warning Center, where you will be taken on a wonderful tour of that facility in the most geomagnetically quiet environment you will find in the Western Cape province. And our current orbiting satellite, of course, is ZA-Cube-2. We are using it to monitor our rich ocean economy. Oh, by the way, South Africa's land mass is 1.2 million square kilometers in area. Guess what? We are surrounded by an exclusive economic zone of 1.5 million square kilometers, which means it's much bigger than the 9 provinces combined, excluding Lesotho and Swaziland. So South Africa is truly a rich country, not just from a rich heritage, not just because it has minerals. What is increasingly making us the contender in being the richest country on earth is our human capital. That is why I'm passionate about human capital development. This is my story, and I'm sticking to it. I remain Daniel Abednego Matsapola, Science Engagement Manager at SANSA Earth Observation. Thank you very much.
Thank you so much, Mr. Matsopela. Absolutely brilliant as always. I'm completely enthused. I'm going to go back and study and become a science GIS remote sensing specialist and okay, maybe a geography teacher. Pam, over to you to introduce our next speaker.
Thank you, Bridget. Dan, really, that was superb and it got me so excited again. I'm sorry that I'm now out of the school system, but I'm really keen to have a school where I can go and start a science club. So I've got a few ideas. I need to chat to you because I do think this would work very well. And I would look at GIS and remote sensing to start with. So we have Cartosa presenting next, and we have two really unassuming gentlemen from Cartosa. And some key qualities or key features we can associate Cartosa with is open source data or information systems and a passion for QGIS. And QGIS is open source, which means you do not have to pay for expensive products. It means we can get the person in the street, the people in the street, linked to these applications, and we can get them going. And that's one of their key promoting factors. They do a lot of other stuff, but it's very important. So I think it's very important to remember those words. So we have Gavin Fleming, and we have Admire Nyakuja, who's going to, both of them are going to speak. So I'm going to talk about Admire first. Cartosa was started in 2014. And so Admire has been with the company since then. And obviously Gavin is the co-founder of Cartosa. He'd also worked for AfriSpatial before that, which was Gavin's previous company. So what is Admire's training? He has a BSc in applied remote sensing and GIS. So you can see once again, he had focus and direction in his studying, and he's passionate about what he does. So he actively contributes to the QGIS project, mainly looking at plugins, but he also is the man behind the scenes of our map downloader for SAGTA. Gavin, believe it or not, studied for an MSc in genetics. So this is quite far removed from genetics, but he did start his GIS career in 1996. So he worked for GIMS, CSIR, Mintech, Scion before starting his own companies. And as I've said, he is really passionate about promoting FOSS4G. So it's your open and free and open source software, open data, open philosophies. And I really think that it's worth pursuing. We need it in this country of ours. So they're going to each talk. I'm not quite sure who's speaking first, but we really appreciate their time and efforts. And as you will all know, the Map Downloader project has really been a hit. And thank you for all the time and effort that you both put into that project. So over to Cartosa.
Admire, if you're ready, go for it.
Okay, I'm ready. I'll share my screen. Okay.
Let's stick your video on if you have.
All right, I've got my screen. Can everyone see?
Yep.
Okay, so I'm going to talk about the GIS and remote sensing, and I'm going to touch a bit about how I got into GIS and just show you a bit of some inspiration in terms of how you can get started in the GIS field, right? So just to begin with, some light humor. I hope all of you didn't get lost to get into this meeting, and if you were lost, then you need to start thinking of your spatial orientation to see if you can get yourself in the right place next time. Right, so Myself, what I studied is I am from Zim, so I managed to do my A levels in Zimbabwe. I did mathematics, biology, and geography. And when I came to South Africa, I initially had come in to study my BSc at University of Fort Hare. And whilst I was doing my BSc, during my first year, I was looking for some courses to do. And one of the courses that I really wanted, because I'd done geography in my A levels, was to do geography as well. And whilst I was choosing other elective courses, someone told me I had a brother who was studying there, and he told me that there is this course that's called GIS, and I enrolled into it first year, and then from there onwards, it took off. And then when I finished my BSc, I realized that there was being offered a higher degree in applied remote sensing, and then I took that applied remote sensing, and ever since I've been loving doing GIS and doing a bit of remote sensing work that we do at Katoza. Right, so the most important thing that all people that come to us, like for instance, if we get in a couple of interns that are doing grade 10s that come to us, they always ask us, so you're a remote sensing specialist, you're a GIS specialist, what is it that you do, right? So this is just an interpretation of how people view the GIS domain or the remote sensing domain. Some of you, they think that we just do an easy job, and some of you think that we really complicated scientists. But as you're gonna see in later applications that I will show you and Gavin will show you, that it's quite an interesting trade that we are in that allows us to do a lot of things in the GIS and make a lot of special decisions. A lot of people, they've inherently started using GIS by the Uber, right? Once you Uber, you automatically know that in the background you're using somehow you're using a bit of GIS, and there are a lot of applications that people do inherently without knowing that they're actually doing a GIS. Like for instance, even if you are in your home, you want to have a certain special orientation to say, I want to put this thing here so that I can be able to navigate my room. That's a bit of spatial orientation. So every one of us has got a bit of spatial orientation. So we need to just harness that and make sure that we utilize it in a proper way. Right. So in the context of what we actually do, this is what we actually do. We create maps and we use a lot of data that we have. Some of the data is open source. Gavin is going to talk about it. And some of the data that we utilize is remote sensing data, like satellite images. So we say, if you have got a satellite images, what decisions can you make? So the picture that's right there, the corner, the flashy one, it's basically showing in a tool that we have got in QGIS that was developed by Katoza. That's a disaster management tool that actually can give you, if you've got your data, you put it in a GIS, you can interrogate and answer a couple of questions to say, if there is a disaster like a flooding disaster, what are the things that you are supposed to do after that flooding disaster? So a GIS can help you to answer those questions. But in the context of remote sensing itself, remote sensing helps you in that it gathers a lot of data, and that data is there once a flooding event happens. Instantly you can get it. Once the flooding happens today, tomorrow there can be data for that. So remote sensing allows us to capture data like that and utilize the data in a GIS. Right. So in terms of your career choice as a GIS geography, you are quite privileged in the context that there is a lot of things that you can do once you are a geographer, a GIS specialist, or a remote sensing specialist. All these fields that are indicated here, they inherently somehow rely on some special things. And so you can work in all these other fields. If you are a geologist, you can do exploration geologist. That requires you to analyze satellite data and you can detect where minerals are. If you are a hydrologist, you can also use GIS and remote sensing data. So all these fields that are being shown here, they somehow rely on GIS and remote sensing data. For security defense, people are using the US government, like the first speaker was telling us, that they somehow use remote sensing data to spot whatever it is that they are spotting, whether it's legal or not legal, it's another story. And another thing that people always ask as well is, am I going to get paid enough, right? So yes, you can get paid enough in this field. There is a bit of some tires that you need to migrate. So once you migrate into the proper tire, when you start at the mid level, you get a certain amount of salary, and then as you go up, your salary increases as well. Right. So I'm not going to explain the basis of remote sensing, but I just thought it was just nice to just bring your mind back to see this diagram. You've seen it in your textbooks. This is what remote sensing involves. And so what are the key benefits of remote sensing, right? So remote sensing is primarily used as a surveying and data collection technique, right? So you imagine in a normal GIS, people go out with GPS surveys. With GPSs, like your phone is a GPS, you can collect data with that, but you can't collect data on a large scale when you are using GPS. You are restricted to a small particular tract, and remote sensing allows you to collect large swaths of data, and this data you can utilize it in a GIS, and there's a lot of different softwares that can be used in terms of manipulating the remote sensing data. Right. So what are some of the applications that people can utilize remote sensing, right? So people can utilize remote sensing in agriculture, right? So I just highlighted the key things that can be applications that remote sensing can do. In agriculture, you can do crop type classification, right? The satellite image passes over a farm and you give it to a remote sensing analyst. They can basically create what's called indices that can help identify whether the crop is growing healthy or not. And that can be used as well in fertilizer application, right? And you can also do forestry and geology, mineral exploration, and you can also do land use and land cover, right? In one particular good example that in land cover and land use is the land cover map that's done in South Africa annually, where people want to see where particular features are on the Earth's surface. Right, so this is just an example of some indices that are the vegetation indices, right? So if you are a remote sensing specialist, right, you are most likely used to getting to see things like this, the indices like this. But for someone who might be just starting in the GIS field, if you give them to interpret this data, they might not know what it means. So a remote sensing specialist has got that advantage that if you give them a satellite image, they can deduce information from that satellite image, and they can tell you the condition of certain plants at a particular time of the year, depending on the satellite that they are using for visualizing that. So this is just one type of work that a remote sensing specialist can do. Is you can be employed by a company that's doing farming that want to monitor their plants for the rest of the year. And then just a brief example of what a remote sensing specialist can do, right? There is also the end product where you can do data interpretation, where you can calculate the color composites that are there. And the technical part about it is you can also help if you've got a background of a bit of engineering. You can also help in terms of preparing actually the flight plans and configuring the sensor, and so that the satellites can collect data that's quite accurate. Right, so this one example of a remote sensing of an application that's in South Africa that uses remote sensing data. That's called AFIS, Advanced Fire Information System, that monitors active fires that are within South Africa. So at the heart of AFIS, it uses a lot of remote sensing. It looks at the different satellites that are there, and it measures some spectrum from there, and then identifies to see where there are fires in South Africa. So This is just one example. There are many applications that are geared in monitoring, remote sensing applications. Right, so I just end with this quote here that I'm told there are people who do not care for maps, and I find it hard to believe. And that's my story as well. Right.
Thank you, Edouard.
Okay, any questions? I'm going to stop my stay.
Okay, I assume we're going to just seg straight into me. Gavin Fleming here. Yeah, I started Cartosa 2014. Ma's been working for AfriSpatial and Cartosa for nearly 10 years. Thanks for that presentation, Maya, and thanks for a great presentation, Dan. So Cartosa is a fairly small company, about 18 people all over the world, 5 different countries. And we do remote sensing and GIS software development, support, training. We are one of the sort of places that you could be employed at if you study GIS and remote sensing. I'm going to dive straight into, we actually have an internship program. We've got some interns with us at the moment, but we focus on once you've finished your degree, you can do an internship with us. So as grade 10s, you've got a while to go, but it is a great career. It's growing in leaps and bounds around the world. You can't go wrong doing GIS and remote sensing. Right, so I'm going to talk about 3 different projects that we are busy with at the moment that involve some type of remote sensing. And the first one actually is related to SANSA. And we are working in a team of people that are building this thing called an open data cube. So SANSA has been collecting satellite imagery for 50 years. They've got Landsat data going back 50 years, and other satellites not as big an archive, but still for many, many, many years. Petabytes of data. It's very difficult to get that data. If you want a satellite image now, you might have to send an order through and send a CD-ROM or a hard drive to SANSA and get it, or do a big download of a few gigabytes. This Open Data Cube thing is open source, an open source tool that actually the Australians developed initially, but it's open source, so anyone can use it and work on it. And so it's running in Australia. There's one running in Africa. There's a few running in other countries, and South Africa is starting its own project with Open Data Cube, and it's hosted at SANSA. It's not ready to see yet, so I haven't got any screenshots of it, but I've got some shots of other ones in other one in Africa, and basically it puts together all the satellite data in a format that makes it easy to access, easy to query, easy to do analysis with, easy to make maps with. You can bring it into a GIS package directly from online. You can download it, you can query it, search it, and you can use Python and Python notebooks called Jupyter notebooks to do analysis programmatically. So if you know a bit of coding, then you can do serious analysis with this. So it really makes it accessible to do, it makes all that expensive satellite imagery much more useful to everyone and provide a greater economic benefit than it has sitting in an archive somewhere. Okay, so this is what the African one looks like. Well, this is the website for it. It's hosted at a site called Digital Earth Africa. And the SANSA one is going to have mainly spot imagery, and I think it's going to focus just on South Africa, whereas this one has other satellite imagery from other satellites and focuses on the rest of Africa. And it's already got a bunch of stuff in there. So there are lots of nice resources on this website with examples of applications of remote sensing, like water resources and flood risks, agriculture and food security, urbanization, land degradation, and coastal erosion. There's some nice pages on that with examples and explanations, and access right into the data itself. This is one looking at drought monitoring in Tanzania. The first one's Landsat imagery over time, looking at how the water level in that lake has risen and fallen over the years. And the one below that is from a European satellite called Sentinel, just over a few days in 1 year. And both of those satellites, Landsat and Sentinel, Landsat's from America, Sentinel is European, both of those are free to the public. So you can access that data, whether it's from the data cube or anywhere else, to do analysis, make maps, do what you want with it. This is a web viewer of Digital Earth Africa. So this is a web map. There's a whole lot of data sets available in there. You can go to that site and choose. I'm looking at a particular, that's a whole bunch of different satellite images, all showing one thing, and that's water summary. I didn't see the explanation, but I imagine it's like the cumulative rainfall that's fallen over a year. I'm guessing that's what it is. So in that part of West Africa. And that's, if you zoom out, you'll see a whole globe, and you'll see where the satellite images that are available in the system, what areas they cover and what they show, and then you can actually draw them and explore them. This is the next project. It's called Sinolax. This is a little company in Cape Town that uses remote sensing to monitor cyanobacteria and chlorophyll levels in lakes around the world. This is a lake in Australia, and that is cyanobacteria in the lake. So sometimes algae just makes the water green. It's not a problem, but often if it's cyanobacteria, it is actually toxic and dangerous to swim in, makes the water poisonous to drink, and not safe to do any water sports in. So how do we pick that up from space? This guy that started this company did his master's at UCT, or his PhD actually, monitoring cyanobacteria off the coast of South Africa in the sea. And he took those algorithms. We helped him automate them and build a website and then a mobile app around them. So what happens is every time a Sentinel satellite passes over a dam or lake that's in the system, this system will download the image, process it, detect all the cyanobacteria levels, and publish it on the system. So there, I just clicked through to I zoomed in, clicked on the Vaal Dam, which happens to be very full at the moment, but it's also not very safe. Cyanobacteria health risk is very high. So there are hundreds, if not thousands, of dams already set up in the world for the system. There, I clicked on the link to the Vaal Dam, and that is what it looks like. So it's quite chunky because the resolution of that Sentinel satellite is not very high, but it's high enough to get useful information here. And the white squares, the white pixels are clouds. So you know that you're not going to get any useful information on that particular day. In fact, this is from yesterday. And that colored image across the dam is the levels of chlorophyll, okay? So that could be any green thing, generally algae. Not all of it is cyanobacteria. If you turn off that layer and you turn on the cyanobacteria layer, you'll see there are just some patches around the dam that have high levels of cyanobacteria. And all of that is information. So the graphs at the bottom are time series of cyanobacteria and chlorophyll levels in that particular dam ever since data was started to be captured, way going back to 2002. And then the images that are used to do the processing, which are false color images from Sentinel and true color images, you can also view in this platform. Admire talked about NDVI. That's yesterday's NDVI image around the Vaal Dam. So it's got nothing to do with chlorophyll in the water, but it's just showing you all the land around there. The blue areas are either water or built up areas. The green areas are growing vegetation, whether it's natural vegetation or crops, and the red down to the red areas, which are either bare ground or dead vegetation, like crop ready for harvest. Okay, it's not busy growing. This is the mobile app. that comes off the Sinolax platform. So it's using the same information. Remember, it's all derived from remote sensing to give you like a weather report of your dam. So you can go and download that app on an Apple phone or a Android phone and select a dam that's close to you that you want to know about, and it'll give you daily updated water quality for that dam. If you want more dams, that's when you might have to start paying, but the rest, I think you can subscribe and see data for one dam for free. Right, and then the last project I want to talk about, this is a different type of remote sensing. This is from what most of you might know as drones or UAVs, unmanned aerial vehicles, but the official name is RPAS, Remotely Piloted Aerial Systems, okay? So this is another company we're just starting to work with in South Africa. And you've heard of all these big solar farms being set up around the country and around the world. Well, solar panels don't last forever. They have problems. Birds make messes on them. Dust falls on them. They crack. They have electrical problems. And when you've got hundreds and thousands of panels, it's a very tedious, if not impossible, job to go and inspect those manually. And also from ground level, walking around, you're not really going to see what the panels look like and find those problems. So they've come up with a solution. They fly over these every few months or every year with an aerial system with the right sensors. So they'll have a natural color sensor and a multispectral color sensor that can pick up thermal signals and infrared. And then they have to register and know where every panel is and process that information to get useful data for the owners of the solar farm. So they know where the problems are, where they and which ones are important, and try and make a maintenance schedule to go and fix them. I think this one's in the Northern Cape somewhere. Look at the information on the left, actually picking up temperatures. So as a panel is allowed to operate within a certain temperature range. If you pick up a hotspot, it could be because an electrical component is broken or there's a crack. Or if it's a very cool spot, maybe it's dirty. So that's the type of, after that data has been processed, these are the types of products that they generate for the owner of the solar farm, so they can see where the problems are with real pictures overlain with analytical data, with real information. And that's all processed automatically. We're helping this company actually make it even more automatic and put it on the web so that they can just go potentially around the world and just make it a much more efficient system. Look at that information on the left there, all those different hotspots, different priorities of problems. And then all of that information, the same information that was there on a map and in graphs, here is in a table, because the client needs information in different forms. So that's my little bit, 3 examples of how remote sensing is used in the real world. Thank you.
Thank you so much, Gavin. And Nicholas, if you could just say the thank yous to our 3 guest speakers. Nicholas, are you there?
Ma'am, can you see me?
I can indeed. Over to you.
Okay. On behalf of all the grade 10s listening today, I'd like to thank Mr. Matsapola, Mr. Fleming, and Mr. Nyakudia for your time today. I have no doubt that everyone listening has been able to realize the importance of remote sensing in our world going forward and the career options that are made possible through it. Thank you again very much for your time.
Thank you, everyone. And thank you for staying on those extra 10 minutes. You are free to go and enjoy your weekend. Be safe. Do not party. Look after your team. And questions, please can you write it in the chat. So if you've got any questions, Mr. Matsapola sends his apology, but he's got a big government engagement to attend remotely. But Gavin and Admire are here, and so is Mr. Nsama. Please ask away in the chat if anyone wants to ask any questions. I'm just looking here. There are lots of thank yous. What stunning grade 10s here. Any questions? I think everyone wants to go away on the weekend. I think the presentations were so good that there are no questions necessary. Thank you, everyone, from all of us, and especially from me, for giving of your time. We're very grateful. Thank you.